So now we've come to add and subtract rational expressions. Granted, this process can be a little bit daunting. However, like all things algebra, if you follow a set of logical steps, you should be able to reach your conclusion without too many tears having been shed. So let's look back at adding and subtracting rational numbers. That means going all the way back to 5th grade and remembering that sometimes you have rational numbers, which, by the way, remember, are a number or a fraction with an integer in the numerator and an integer in the denominator. Some are easy to add and subtract because they have the same denominator. 1/3 plus 4/3 just equals 1 plus 4, 5/3. Easy peasy, lemon squeezy when you have the same denominator. But when you have a different denominator, it can get a little bit hairy. You have 1/3 minus 4/6. Oh, yikes. Well, by now you probably know the shortcut, which is to multiply one fraction or both fractions to create the same denominator. So now on the left-hand side, I have 2 times 3 equals 6, which makes it the same denominator. And now I can carry out the rest of my operation. 2 times 1 is 2 minus 4 over, keep the same denominator. And 2 minus 4 is negative 2 over 6, and then always reduce. So negative 1/3. Okay, the part I wrote in blue, you've become natural at doing that without much thought, but I want to remind you, take you backward and remind you the process that you really are doing in the background. First, I'm looking at 1/3 minus 4/6. I'm going to factor the numerators and the denominators completely, or excuse me, factor the denominators. So I have 4 over 2 times 6. So with integers, factoring the denominators isn't all that tough because all you have to do is write them as a product of primes. Okay, so 1/3 is the same as 1/3 minus 4 over 6 is the same as 4 over 2 times 3. If I wanted to write my lowest common denominator, then I would start with my first fraction and write the denominator I have there because I need a 3 to be able to write my lowest common denominator. Then I come to my second fraction, and all I want to do is write enough more numbers to be able to write this denominator. Well, for just my second denominator, I have a 3, and I need a 3, so I'm not going to write another 3 because I have a 3, but I need a 2. So that means my lowest common denominator is 3 times 2, which equals 6. Now, when I write my fraction out again, I'm going to write my 1 over my 6 minus 4 over 6. All I'm doing is keeping my same denominators. I'm not finished because obviously I've changed it up and this isn't legal yet. But I'm noticing that in order to turn 3 into 6, I had to multiply it by 2. And so if I multiply my numerator by 2, then I've essentially multiplied the first fraction by 2 over 2. See how the denominator is right here, the lowest common denominator, and I've adjusted the numerator to match it. So this is the kind of unwieldy math or algebra that's behind the process you've been doing for a long time. So now 2 minus 4 is negative 2, 6, which is negative 1/3. So we want to redo this process. Let me keep my colors. I have a plan. Okay, so we want to duplicate this process not with rational numbers, but with rational expressions. So let's start with an example more like this first one. So if I have like denominators, for example, a rational expression 2x over x plus 2, and I want to add to that 1 plus x or x plus 1 over x plus 2. What do I want to do? Well, this already looks messier, but if I look at it more closely, I notice that I'm adding 2 fractions that have the same denominator, which means all I want to do is add across the numerators. So this is 2x plus x plus 1 over x plus 2. Just add the numerators together, keep the same denominator. Now if I add the numerators, I get 2x plus x is 3x plus 1 over x plus 2. Easy peasy. What if I have something a little bit less complicated in the denominator but more complicated in the numerator? 4x plus 1 over 5x minus x plus 3 over 5x. Again, I look first at the denominators to see, am I dealing with like fractions or unlike fractions? These are like, which means I can just do the operation. I can move all the operations into the numerator. 4x plus 1 minus x plus 3. Notice how in both cases I protected the numerators with parentheses and then decided later whether I needed the parentheses. In this case I didn't, because plus doesn't change any signs inside. But in this case you can see that negative a binomial means negative each term. So let's do that explicitly. So this is 4x plus 1 minus x minus 3. So you have to be really careful about that, protecting your numbers. In this case, the number is a binomial. And when you subtracted that binomial, you have to be really careful about protecting it with parentheses. Okay, so 4x minus x, 3x, 1 minus 3 minus 2 over 5x. Okay, so adding and subtracting rational expressions couldn't be any easier when they're alike, just like adding and subtracting rational numbers. Let's look at a case where they're not alike. Let's add, well, before we start to add and subtract unlike rational expressions, let's first just look at finding the lowest common denominator. So you have a fraction 1 over 12x, or a rational expression 1 over 12x, and you have another rational expression x plus 7 over 4x squared. And so we want to find just the lowest common denominator. Well, I'm going to use the same algorithm here, but let's remind ourselves what that algorithm stems from. So I'm going to come over here and I'm going to write 12x and 4x squared, one on top of each other. You'll probably recognize this from having worked with these sorts of values in pre-algebra. So first I'm going to write it as a product of primes. So I have a 12. You can tell it's early in the morning. I'm making lots of these funny mistakes. 12, it divides by 2, leaving 6, which divides by 2, leaving 3, and 3 is prime, and then I have 1x. For 4, divides by 2, leaving 2, 2 is prime, and then I have 2 x's. And so the process we want to undertake is to remove any duplicates. And that means I want one expression of everything that's duplicated. So I have 2 2's, they're duplicated, in one of them in each denominator or each polynomial. And so I can cross out the 2 2's and write it down one time. So what I've done is really kind of disappear one of them. Do that again here. These don't match, but these match. And then I really need every factor to be in my least common multiple or my least common denominator, which are, by the way, the same exact value. So I have to include a 3 and an x and another x. So the smallest number I can make, or the lowest common denominator, in this case is 2 times 2, which is 4, times 3, which is 12, x squared. And that makes sense, because if I multiply 4x squared by 3, and if I multiply 12x by x, that's the 3 and the x that I need to make these common. I end up with 12x squared in both cases. So that's the work I'm doing. If I use the lowest common denominator algorithm, which is the way I like to look at doing this, and I can leave this first part of it out, then I get 2. That's not what I get. Let me write it out a different way. So the first step in finding the lowest common denominator is to pop, or write the denominator, pop D, right? So we're going to write each of the denominators as a product of primes. I'm going to write 1 over 2 times 2 times 3 times x, which is this one. And then let's go ahead and call this and turn this into addition. Now that we've covered the least common denominator part, let's add these two together and see what we get. So the second fraction then has the numerator x plus 7 over 2 times x times x. And we want to remove the duplicates to find our lowest common denominator. So I need every factor, just like here, right? I needed every factor to be able to make my 12x. I need every factor of the 12x, but I'm going to multiply in an additional x. But we're not there yet. So what that means is I want to start with my first fraction and write every factor down. 2, 2, 3, and x. 2, 2, 2, 3, and x. That's my 12x. Now, here's where we're going to get rid of duplicates. This 2 is already there, so I'm not going to write it. Actually, let me even change my my scratch out a little bit. All right, so let's do this. This 2 is already there, so I'm not going to write it. This 2 is also already there, so I'm not going to write it. And this x is already there, so I'm not going to write it, which means all I have to do is throw in another x. That's exactly the same thing I did here. Now, had I started by writing this denominator down all the way instead and done my crossouts on this side, then I would have had to multiply a 3 here at the end. Okay, so the step is write each denominator as a product of primes, pop D. Then create your lowest common denominator by eliminate duplicates. So the LCD is eliminate duplicates. Okay, done. Now, and then you might want to go ahead and say what this equals. You don't have to at this stage, but if it's easy enough, then you can go ahead and do that. And we know that this equals 12x squared. It'll save you a little time in a minute, not necessarily needed. Now, the next step, so that's 2. The third step then is we're just going to set up a place where we can make the change in the numerator that matches the change we made in the denominator. So first, I'm going to start with my numerator of 1, and I want to write it over my lowest common denominator, 12x squared. Then I want to write my numerator x plus 7 and write it over my 12x squared. Okay, so this isn't finished yet because these are not the same thing. You can't just change a change a fraction to have the denominator you want. You have to alter the numerator, just like we did here. We couldn't just turn this denominator into a 6 without changing the numerator to fit. And so we're going to do the same thing here. And so the question is, what did we do? Well, if we look at this this denominator, what did it take to turn the original denominator into 12x squared? Well, I had to multiply this x because everything else is the same. 2, 2, 3x, 2, 2, 3x, and one more x. I multiplied this x into the original denominator, which means I have to multiply it into the numerator as well. So what happened on the second fraction? Here's my numerator. I have a denominator of 12x squared. I didn't start with a denominator of 12x squared. I started with 4x squared. So what did I have to multiply into this one? Well, 2xx. I have 2xx. This is easier to do on your paper because you can cover up, like you could put your finger on top of the two denominators. I just did it, but on my electronic paper, it doesn't really show. So you could put your finger over top of these two 2's and these two x's, and what you'd see left over that you multiplied in is the 3. And so I'm going to multiply 3 into this numerator. So now I've changed both of the numerators so that I have a common denominator. I've done exactly what we do up here, only I've had to take a couple extra steps because I don't have easy numbers like integers. And now everything is just the same. So that equals 1 times x plus, let's do some protection here, 3x plus 21 over 12x squared. Running out of room here, so I'm going to go sideways. I don't like it, but I'll do it if I have to. So this is x plus 3x plus 21, just meaning that I distributed the plus, so none of the signs had to change. 12x squared. So that's 4x plus 21 over 12x squared. Done. So the next step of the numerator is to adjust, or excuse me, after you've made the lowest common denominator, you want to adjust the numerators to write like fractions. To create. So that's my way of adding and subtracting rational expressions. And I bet at this stage of the game, you're thinking, why on earth would she take something as easy as this and turn it into all of this? I'm about to show you why. Because like most of algebra, just when you start to feel like you really know what you're doing, you find out, oh, maybe not so much. But if you have a really good algorithm, an algebraic process, you got the method you need to carry you far. So this time our rational numbers look like x plus 4 over x squared plus 3x minus 10 and minus x minus 1 over x squared plus 2x minus 8. Okay, not so easy all of a sudden, is it? That's okay, we have an algorithm. First thing I want to do, step number 1, is factor the denominators. Okay, so let's do that. X plus 4 over x, negative 10, so one's going to be negative and one's going to be positive. And two numbers that multiply to give you 10, but add to give you 3, it's going to be 5, obviously. And so I want the plus 5 and the minus 2, 5 and 2, plus 5 minus 2 gives you a positive 3. So remember, all I want at this stage, because we've already done our unit on factoring, you don't have to show me the methods that you use, you just have to get right factors. So if you want to use a piece of scratch paper or scribble off to the side, totally fine with me, but your factoring should no longer be inside of your problem. You don't write the factoring down, you just do it in your problem. So the next one is x minus 1 over, well, this is going to be x negative 8 combined to give you 4. It's going to be a 4, combined to give you a 2. It's going to be a 4 and a 2. And the plus 4 minus 2 guarantees a positive 2. So now I can write my LCD, right? Factor the numerators. Now I'm going to put together my lowest common denominator. Start with all the factors of the first fraction, x minus 2 and x plus 5, and then remove duplicates to create the second denominator. So x plus 4 is in the second denominator, and I don't have an x plus 4, so I'm going to go ahead and do that. And then x minus 2 is in the second denominator. I need one, but I already have one. So notice, if I just wrote all the factors down, I would have 2 times. I'd have an x minus 2 twice. We want to get rid of that duplicate, so I only have one of them. So in this case, I'm not going to expand to see what it equals, because that'd be crazy. Who would expand that if you don't need it? So later, if I need it, I'll do it. But if I don't need to, I'm not going to. So now we're going to write x plus 4. Just making room to adjust the numerators over, and in this stage I like to write LCD, because why write all of this every time, or 3 more times? So I have the first fraction numerator over our new lowest common denominator minus our second fraction, x minus 1, over our LCD, right? Because that's the whole goal here, is to make them like fractions. So now they're both alike because they have the same lowest common denominator. But what did I have to do in order to make the lowest common denominator? If I look at this first one, x plus 4, the denominator used to have an x minus 2 and an x plus 5. I had to multiply x plus 4 into it in order to make it a lowest common denominator. So I have to multiply that into the numerator as well. Okay, I'm going to erase these little lines. On your own paper, you would just want to use your finger to cover those up. So in the second fraction now, I have an x plus 4 factor, and I have an x minus 2 factor. The one that's missing, or the one I had to multiply to turn this number into the lowest common denominator, was x plus 5. Now I can finish out my problem. And granted, at this stage of the game, it's a little bit tricky because there's a fair amount of algebra here, but or a fair number of calculations, but at least you don't have to worry about the common denominator thing. So I'm going to take this, subtract this, which means I want to expand these two fractions or two factors. So I have x squared plus 8x plus 16. And notice I didn't do my rainbow and write all of my terms and gather them out. Again, we have finished that unit. The expectation now is that you know how to do it. It's not the expectation yet that you be perfect. In the meantime, you're welcome to use scratch paper or work off on the side, but it's not part of your problem anymore, okay? And then minus, and this time remember, we want to protect our numerators. So let's go ahead and group those, and then minus, we're going to group this. X squared plus 5 minus 1x times negative 5. All over, and I'm going to continue to write just my LCD. Okay, right up until the end I'll do that. It's just a shortcut. Makes it easier for me not to have to keep rewriting that. So x squared, well, what does this mean? This minus means I'm going to subtract this entire number, which means I'm going to subtract each part in turn. So let's change all the signs inside and then turn it into addition. Now I can combine all my like terms. X squared minus x squared, those disappear. 8x minus 4x is 4x. 16 plus 5 is 21 over, now I have to actually write my LCD, over x minus 2 times x plus 5 times x plus 4. And at this stage, you could distribute all of these. I think that's crazy. Don't do it unless you have to, but it's as reduced as it can be. I've combined my numerator and I have my lowest common denominator. All right, so here's my argument for this process. Look at this problem. This was a big old hairy, ugly beast of a problem when we first started, and it took me 1, 2, 3, 4 steps to finish. Look what happens when I have a super duper easy problem. This is really easy. This one took me 1, 2, well, let's see, 1, 2, 3, 4 steps to finish. This one, I didn't need to specifically write the LCD algorithm, but look, 1, 2, 3 steps. The only thing missing is the LCD algorithm. I've basically taken this giant hairy monster and turned it into something as easy as this. I think that's a pretty healthy thing when you're trying to work with big hairy monsters to turn them into little tiny teddy bears. So add and subtract rational expressions, follow a set of logical steps, get there.